The focus of this lesson is on combining functions, and in particular we're going to deal with division of functions in this example. So we're going to take f divided by g of x, which is just f of x divided by g of x. So those notations look different, but ultimately they are the same. So it's just your numerator's function divided by your denominator's function. So your numerator's function is f of x, so that's square root of x plus 2. And your denominator's function is g, which is g of x is x plus 5. So ultimately that is the division, and so you're done with that division problem, if you will. So then you're going to go ahead and move on to the concept of domain for functions that you're dividing. So when you're dealing with the domain for division of functions, what you would do is you would consider the domain of each of the functions, so both the f and the g. So we need to consider the domain of f, and we need to consider the domain of g. But not only that, we also, on top of that, have to exclude any values that make g of x 0. So any values of x, so we're going to exclude x's here, that make g of x 0. Okay? So we're going to look at those three things. We're going to basically take the intersection of the domain of f and the domain of g, but we're going to also exclude those values of x for which g of x is 0. So let's look at function f first. So f of x is the square root of x plus 2. Since it's a square root, we know what's underneath the square root. The radicand needs to be positive or 0. So that means x plus 2 can be greater than or equal to 0. Solve for x by subtracting 2 from both sides. You get that x needs to be greater than or equal to negative 2. And you can kind of, if that helps you, you could draw it on a number line. But here's negative 2. You could be negative 2 itself or everything bigger. But that's not our domain of f divided by g because that's just the f piece. So we now need to look at the domain of g itself. So g of x is x plus 5, which is just a polynomial. It's actually a line. And if you think about a line, its domain is all real numbers. So if you think about the graph of a line. But another way to think about that is no matter what you put in for x, if you add 5 to it, it's still a real number. And so everything works. And so the domain is all real numbers, which again graphically is just everything. Okay? And then, is there any x values for which g of x is 0? So again, I want us to look at g of x. So I'm going to kind of write g of x down. It's x plus 5. You could probably see right away what value for x would make that 0. But if not, set it equal to 0 and solve for x by subtracting 5 from both sides. And you'd see that when x is negative 5, your g of x is 0. Well, that's not allowed, so we would have to exclude that from our domain. So now we're going to put all these pieces together now. So the domain is the intersection of these two, which, if you think about if you put those two graphs together, where do they overlap? They overlap from negative 2 to infinity. But then on top of that, you would also have to exclude x is negative 5. But notice that negative 5 is not in that interval. It's already excluded because this interval includes negative 2, negative 1, 0, 1, 2, etc., and every number in between. I'm just saying the integers. But notice negative 5 is not in that, so we don't have to go out of our way to exclude it. But normally we would if it was already falling in that interval. So at the end of the day, if we put all three of those pieces together, our domain of f divided by g is negative 2 to infinity.